Good evening. Thanks for coming. I'm Diego. I come all the way from Spain for this talk. It's not true, actually. But it feels well. So I'm talking about Conan, okay? So sorry, it's not going to be about this Conan, but probably you wonder about the name. So you know how difficult it is to come up with a name that is not taken by domainers? I hate domainers. They should go to hell, or they should make code in JavaScript, for example. But the truth is that we were joking, and Conan was easy to remember, was easy to write, and the domain was available. So it was like a no-brainer. We just went for it. So what is Conan? Conan is actually is the missing link of DevTools. It's the package manager for C and C++. Sorry to put them together. I know they are different, but for DevTools, it's exactly the same. So Conan is a free and open source package manager, MIT license, and it including the server. So you can run the server in-house because it is Git-like distributed. So you can get artifacts from our server, for example, and upload them to your own server in-house, okay? Similar to Git. It is build system agnostic. I came from a previous startup. It was called bcode.com. It was also a dependency manager. We had to close it. So we had a lot of experience. One of the things we realized that it had to be build system independent. So now we use CMake a lot, but we also support other ways to consume packages that is not CMake based. And the one thing is we have tried very hard to not create any lock-in into the tool. So we'll see after. I have some slides, but actually I'm trying to do something live. So this is my machine. It is Windows. Don't hate me for that. I have reasons. But it's, besides that, it's a pretty standard machine with Visual Studio, CMake, Python, the typical tools. I've just installed Conan with pip, and I have a simple example here, but I'm going to switch to live coding. So I have a small project here. The source code is just an example. It is using the Poco libraries. Probably you know about the well-known Poco libraries, Poco project. It's doing some stuff with timers and callbacks. And then I'm also using the Boost regex library as an example too. Here we can see the code for Boost regex. So besides that, it's pretty standard code, right? I have my include directives. So what I need Boost and I need Poco, right? So what I do is I write a Conan file.txt file that looks like this, okay? I declare my dependencies, the name, the version, the author of the library, and also the channel. You can have testing channel, you can have many channels as you want. Then I declare my build system. I'm going to consume these packages with a CMake project. And then I also declare my options. In this case, I'm going to consume these libraries as static libraries, yes. So what I'm doing here, okay, I'm going to create a build directory. I'm going to switch to it. And I'm running Conan install to the upper level, which is the Conan file lives. Okay, so I'm cheating here. I didn't want to depend on the network so much. So the dependencies were installed. Actually, it would have to download. It would be like 1 minute downloading Boost and Poco because they're large. But what I've got here, I've got the dependencies installed. I can see them. They are installed there. I can inspect my dependency tree. It will take this is a bug, it's checking for updates. It is already solved, there's a pull request open for solving this delay. So here I can check my dependency tree. Every dependency, like Boost, is required by the project. It requires setlib, for example, the licenses, and so on. So you can inspect the things you want to know typically about your dependencies. And what is important is that this Conan install has created a file for me. We can check here. It's called conanbuildinfo.cmake. This is actually a standard CMake file. I'm going to open it so you can have a look. So what you have inside this file is just a set of variables, CMake variables, defining the include directories, the libraries, the flags you need to link with. For every library you are depending on, and also all of them together, because typically the order of libraries in the linkage matters. So we generate also a variable with all the variables in order, so they are ready for use. Then I have this file. All I have to do to build this project is to create this CMake list file, include the recently created file, and I'm here using a macro, a predefined macro, that is doing some stuff like setting the actual include directories, the libraries, and so on. But you can just grab the variables and use the way you like. And finally, create the executable and link with the libraries that the file is defining. So this is all I need. So now I can actually build my project. With CMake. A bit slow on Windows, and then I can already build the project. Okay, that's it, and I can run my example. Here is running the POCO code, and then the last true and false are the Boost libraries. So I've just depended on Boost and POCO that in turn depend on OpenSSL on Windows. It's pretty cool. And also there is a diamond structure of dependencies because both of them depend on setlib. So I've set up everything and built a project like this thing. So I'm here using one configuration. What happens if I want to build, for example, 32 bits binaries? So then you have to install a different binary. Okay, I will talk about that later. So I have to remove things. I will install, specifying that my settings now, the architecture is going to be plain x86 instead of 64 bytes. So I'm going to install different packages, 32 bits packages, and then the rest of the process is exactly the same. Just configure the project. Yeah, CMake is much fast. Oh. A standard CMake stuff. Yeah, it's the network connection. So now I'm going to build the project. And this will be 32 bits binary, my executable. Hey, what happened? No, the demo effect. Oh yeah, sorry, I made a mistake. Probably some of you realized I have to, I'm going to clean my cache and CMake files. That would be good enough. So I made a mistake because I used the 64 bytes generator. I'm using 32 bits packages. So I will try this one. And build. Yeah. And we have this. Okay, so you can say, hey, Diego, I'm not going to grab the binaries from your system. No problem. It will, if you want, it can build the packages from sources. Just when you specify Conan install, then you can specify build, like this way, like build. I'm not going to do it. It's this Boost and POCO. We want to finish today, but it will build the things, and it will work exactly the same. What happens if I don't want to use CMake because I'm using just Visual Studio for my project, and I want to keep with my pure Visual Studio project? So what I can do is use the generator, and then I will declare that I'm consuming with Visual Studio, right? And then I will run Conan install. Again, sorry, it will be Conan install s arc Okay, so now it has generated a file that is suitable for Visual Studio. So I can go for, I have a predefined Visual Studio project here. Oh, sorry. This is a regular one. It's not generated by CMake. It's just a plain Visual Studio project. So I go here, and then I can search for the thing that has been generated. And build the solution. Yep. Debug, start without debugging. And we have our application built with Visual Studio directly without. So some packages that they have been created with CMake, with Auto Tools, or with, I think OpenSSL in Windows is built with Perl, actually, and I'm consuming them directly from my Visual Studio. So now, what about, okay, so for consuming packages is seen. Now we are going to check, sorry. I think I can close this. I will show you. Here is the recipe I have to write if I want to package an existing library. So this is going to package. I'm going to create a package for a library I have. It is here in GitHub, pretty standard, just a hello world application with a hello library and the standard hello world message. The CMake list of the library is also pretty standard, just plain CMake stuff. Okay. So what I have to do here is to define a recipe. It is somewhat similar to Homebrew Ruby recipes, but in this case it is Python. There are 4 important methods here. We have the source method, in which you can specify the source code origin. In this case, I'm just cloning the repository. Then you have to specify your build. And then here you can wrap any build system you want. Just run it. Here you can see that I'm just running CMake. I have a helper for CMake, okay, but you can run any system you want. In fact, last week I tried to create a project with Visual Studio modules, C++ 17 ready, and it works. You just have to call CL compiler, and it will do the job. Then you define the package. Actually, here you are extracting the artifacts, the headers and the libraries, the binaries, and then you are copying them to a package folder. And finally, you are specifying the flags. And in this case, for example, the library name is enough. It's something similar to PC files. You are declaring to your consumers what flags do they have to use. You don't want them to guess what is the library name or the flags they have to use. You declare them. The package creator declares them, so it's ready for the consumers. So I write my recipe, and then I have to Conan export under my username and a channel. Let's call it testing. Okay, so I have already my package ready to be used in my machine. This has registered the recipe into my local storage, not in the cloud, anything, in my storage. And in my storage, it's ready to use. I can already use that package. For example, I could just Conan install. I'm going to install this reference. It's going to be called hello, the version 0.1. And then from Diego testing, if I do this, it's going to complain because he cannot find a binary package. It has only found the recipe. Okay, so if I want a binary package I can actually use for the library, I will just use the build. It will clone the original GitHub repository. Then it will launch the build method running CMake and building the actual library. And then, yeah, and it will just create the package. So the package now is ready. You can check Conan search. Hello, let's make it a bit verbose. So you can see here that I've created a package for 64 bytes, release Visual Studio 14 in Windows. Okay, so I've created this configuration. So this is what I've shown you. And now, okay, that looks pretty simple, okay? But we are in a C++ meetup, so we actually are not afraid of complex things, and we have to deal with complex things every day. So Conan has to provide something more powerful to create packages because our builds are going to be more complicated than what I've just shown. So I'm going to deep dive a little bit more on the creating packages thing. First thing that you have to have in mind is that we have a recipe, and from that recipe you can create many packages, many binary packages. Every package will have a different ID, okay, for every different configuration. For example, if you are building for Visual Studio 14, it's not going to be compatible with Visual Studio 12. So every configuration has a different binary. What you have to declare in your recipe is the factors that affect your binary. In this case, we are telling the system, okay, the operating system, the architecture, the compiler version inside the compiler, and the build type, release debug, change my binary. It's going to be a different binary. And typically, you won't be able to link a binary that is not matching your configuration. Also, if the settings are for all my projects, it's going to be the same for all my projects. The options are just for your package. So in this case, this package can be static or it can be dynamic. So you have the option for this concrete package, and you define these things. For the values, we have several predefined, for the settings, sorry, we have different predefined values. That doesn't mean that you cannot use other values. This is a file, and you can edit it. Who is using, for example, GCC 6? Someone is using at work? Yeah, GCC 6? Oh, the IMC people are up to date. So, for example, if you want to use GCC 6.1, you can just add it to the file, okay, and it will be fine, even if it's not there. So these settings are actually the process we have been, while doing releases, we have learned what the typical settings are. For example, the standard library. Initially, we thought that from GCC 5.1 to upper, you will be able to use always the standard library 11. You know that this is the default one. But it is actually not true. If you're using an old machine, not so old, but maybe an Ubuntu 14, and you upgrade your compiler, you install GCC 5.3, your default standard library will not be 11. It will be the old one, because otherwise the system will break. Some applications depend on the standard library that is installed on the system, so maybe you can play and install it in a different directory or whatever, but it's not the standard. So if you're running in Travis continuous integration and upgrade your compiler, then you will be using the old library. If you have a modern distribution, then you're using the modern one. So then you have ABI incompatibility. So that's why the libcxx is a setting for this compiler, because you actually can choose which one, and it's not really coupled to the compiler version. These settings, they affect the build. For example, if we are using the CMake generator, we'll have to do something like this to translate the setting to the CMake, or in this case, to GCC variables. But the important thing is that the settings and the options and also their requirements, because if you require some dependencies, then your binary will also change if you upgrade the dependencies. So all of these things, they are hashed together, and they define the ID of the binary package. Okay. Actually, in dependencies, we are using semantic versioning. We are assuming if you keep the minor, it will be ABI compatible. So you can just run with that pattern, and it will be fine. If not, you can change it. So you can define, okay, my build is affected by minors, by majors of my dependencies. Then what I've shown you is the out-of-source way of doing things. So I'm just git cloning from a different repository. It also allows the in-source. So you can have the recipe, you can put it inside your project, inside your package, and then it will make it like a snapshot. It will just copy all your source file into the package recipe. So you don't have to depend on external sources. It can package all the source together, and then you don't have to rely on GitHub, for example. There are two different approaches to where do you want to get your sources from. Then this is, for example, a typical example that you can download and extract a zip file for, in this case, for the Poco project. Then we also have configuration. And a typical use case would be conditional dependencies. In this case, the Poco project can use SSL or not. It depends on the options you choose when you depend on Poco project. If you say that you want to use SSL, then you have to add the dependency to OpenSSL. And if you say no, then so the dependency in this case is conditional, depending on your own options. And then a typical thing that you will have to do if the build system of the library has different semantics. For example, Poco in this case is using this flag Poco MT. So you have to translate the Conan settings to the variables the concrete build is using. And then finally, you have to define your package information. So you will do things like this, something that is really annoying when you depend on libraries, and then it depends if it is debug library or whatever, it changed the name. And you have to be changing the name on your environment. This is now up to the package creator. It will define, okay, so my library will be named like this, and it will be defined for the consumers automatically. They can also, package creator, they can also pull in system libraries, saying, okay, you will need pthread and DL and RT for building this. So these are going to be actual dependencies. And they can also define like variables, like the definitions you have to add to your build, so your build actually builds against this library. Finally, this is for creating packages, but what happens when you already have built your package? Then you can upload anywhere. You can upload to the Conan.io server. We are running it. It's free for open source, of course. But you can also run your own remote. In this case, it is exactly similar as Git. You can, for example, you can get artifacts from the Conan.io server. You can rename them to your own username, and you can upload them to your own server. So the typical workflow will be like this. You can get the packages and route them to a different remote, and remove remotes if you want, add new remotes. It's something, and the syntax actually is like Git one. It's Conan remote add origin URL. So finally, I didn't want to do a lot of details about these things, but we are providing like a separate tool for creating packages. So actually, when we want to create the Boost packages or so, we are using Travis continuous integration, we are using AppBayor, and we are using Docker in the cloud. So for a package, you just use this tool, git push, and it will fire like hundreds of builds in those systems. Someday they are going to kill us because we use so many hours of builds, but it is actually working. So integrating with continuous integration is very easy in this case. The Conan package tool, what it does is just generate combinations. Okay, for visual, for example, generate visual 14, 11, 10, release, debug, it creates the combination, and it fires one build for each one. So I wanted to keep it technical. Maybe you are wondering if we are doing fine or not. I'm going to be very brief. If you have interest, just ask me after the show. So we launched 5 months ago, and it's doing pretty well. I mean, I know the statistics we used to have at Bcode, and this time we are doing much, much better. The GitHub repository is amazing. A lot of contributions so far, and also we know of some companies that we are in beta, but there are some companies that are already using it in production. So important one. So we are very, very happy with it. This is actually the actual API calls to our servers per week. So it is growing like at this pace. So finally, now there are like 3 alternatives. You can be either this guy. That's not possible because this is me. maybe you are this guy and you don't need dev tools at all. But for the rest of us, if you might think that Conan would be interested for you, I will be here in Sydney for 1 month. So if you want free training, you want me to go to your company, talk to you, check things out, I will be available. So just drop me an email. I will receive those emails. So just right there, and I would love to go and meet in your company, and I will be at your service. So that's it. That's it. Thank you. Thanks very much for your attention. So, time for questions, I guess. Any questions over there?
Hi. Great talk. Conan looks very cool. I was wondering what your roadmap's like. Are you going to be building packages like Debian and MSI packages and RPMs? Is that on the roadmap, or?
If we are creating packages ourselves, not really. We are trying. Of course, we have built several packages like Boost and OpenSSL and some of them, but we are trying not to create them and let the people create them. So we are focusing right now on the technology and that things run smoothly. We have packs and everything, and we are not so in creating packages because actually the companies that are using it, they don't need the packages so much. I mean, 90% of the dependencies, they are their own dependencies. They depend on Boost, but it's already there. So the external dependencies are not so huge. So actually, our current model right now is we are not creating packages. Some companies have requested us to help them to bootstrap their projects creating packages. So we have done some kind of consultancy for companies to help them create the packages they need. But no, I mean, now we want to keep it lean. We are not venture capital backed. Because we had venture capital, now we are running ourselves, and we want to keep lean. And creating packages and testing and everything requires quite a lot of effort. So I think it will be fine with the community because it's growing fast. And so packages, now there are a few packages, that's right. But I guess that will not be a problem at all. As long as the tool runs smoothly, it's going to be fine. Thank you. Any other question?
You didn't say anything about libc dependencies in your talk. Dependencies on libc, how do you handle that? In your examples, the OS was just set to Linux. What happens if you download a package but it was built for a newer version of libc than you're trying to run it against, for example?
Sorry, I don't get the question. If you depend on setlib?
No,
right?
on libc.
Oh, libc.
libc
okay.
and Linux, yeah. Is that something you can also specify as part of your package, the libc version that's assumed?
Oh, yeah, absolutely. So the approach would be, let's say that you are doing this, okay? So you are actually depending on OpenSSL, and so I didn't have to specify them because it's transitive, right? But for example, if a new version of libc goes out, and this guy, they don't upgrade the packages, I just can add it. I will add zlib, like the new version.
I'm not speaking of zlib. I mean the C library on Linux.
Oh, the C library.
glibc.
Oh, the glibc. Sorry, I didn't get the question. Yeah, we have, so far, we haven't had compatibility problems with, so as long as the compiler is the same and the range of operating system we are doing, so the worst thing we have had, okay, it failed like once, and that guy is using just building from sources when he needs, and it will be okay. Yeah, of course, binary compatibility for C and C++ programmers is a nightmare. So you can't expect to have all the combinations of binary packages you need. So we are creating the most common packages, but finally when something fails, then you have to build the package from source, and then you're done. What happens is that typically for actual production projects, it's not a problem because the systems are defined. So we are running in this range of operating systems, and they create the packages themselves for their setups. So it is fine. If you go to Boost in IRM compiler, 32 bits, or whatever, yes, you can have problems, and you will maybe have to rebuild from source. Yeah, but that happens like a few for standard setups, just once in our story. Another question? Yeah.
I mean, do we run into any challenges when we are, trying to make Conan work on the Docker environment?
If we have problem with Docker?
Yeah, no, my question is, do we run into any challenges when we are trying to make Conan work on the Docker environment? Primarily because Docker would let you create the Docker images for any operating system that you would want.
Yeah, actually, we are running Conan on Docker on Travis. So for generating the packages of Boost and Poco and so on, we are firing like 200 Travis builds. Inside each instance of Travis, we are launching Docker, and inside Docker, predefined Docker images with GCC whatever version, and inside those Docker images, we are running Conan to build the things. Actually, the lib std C++ incompatibility, we were aware of it because of Docker. Because in Docker, we were running like a brand new, the latest Ubuntu, okay? But then users, Conan users, they were running like a better Travis. So they were consuming packages created with the same compiler, but in a Docker environment, latest Ubuntu, and they were consuming it with Travis. I think Travis is still 12, Ubuntu 12. Okay, so so to your question is, yeah, it runs perfectly in a Docker environment.
Hey, if somebody was working with some Apache packages, so would you be sharing the packages and the recipes to how to compile those packages into Conan?
Yeah, actually the recipes can be, you don't have to create the binaries if you don't want. You write the recipe, export the recipe to your local storage, and then Conan upload. And it will go, I haven't showed you, but the standard way to share recipes is upload the recipe. So you don't need to create the binary if you don't want. You just write the Python recipe, export to your local storage, upload to the remote you want. And once it's in the remote, I will, for example, look for Poco. Quite slow now. Yeah, and I will check here, for example. So here we have the Poco recipe. You can read it. Okay, you can check the binary packages, but in this case there are binary packages. But you can share the recipe without the binaries if you want. And finally, we have the link to the original package recipe. So the standard workflow would be to define a GitHub repository for your recipe, push it to GitHub, and then create the package, Conan export, Conan upload, and make the recipe available in Conan to users. So yeah, so this will be the recipe in GitHub for this package. So the standard way will be GitHub repositories and then upload the recipes to Conan.
One of the disadvantages with linking against these pre-built binaries is that when something goes wrong there, you often don't have the source code available to debug. Some of the other sort of package management tools have sort of built-in features where they'll bring the source code down as well, so you can step through debug when you have issues. Do you guys have plans to deal or introduce any features to deal with that sort of difficulty?
Oh yeah, absolutely. You can use here when you install a package. Okay, you can specify this is the build type. You can say debug. In this case, the package creator can perfectly copy the sources to the package folder, just as I showed you. I mean, in this case, you will have something. If you want to package the sources, here in the package method, you will just copy the sources to the package library. And then you can in this case, it will be typical also to, for example, if you're in Visual and you want to copy the PDV files, for example, you can just copy the PDV files to the package, and then that's the good thing of Conan. If you want a release package, you get only the bare release artifacts you want. If you want the debug package, then it will retrieve the sources and the PDV. But it's up to the package creator. We don't do anything. The package creator has to decide to package the sources and the PDV or the temporary files or whatever. But it's perfectly, there are people that are debugging with Conan packages.
Does Conan support SSH keys? Because when I try to do a git clone, there are cases where I need to specify the SSH key through an SSH agent, for example. So I was wondering if it gets specified as part of the whole recipe.
Not now. Not now. Everything is HTTPS, but I'm not sure if you can run it on an SSH tunnel or something. There are some provisions for proxies, so you can run a proxy or something, but SSH tunnel, I think right now, no, it's not possible. But just open an issue on GitHub and ask for it. Or better, make a pull request with it.
So with your CMake example, the one you showed first, can you go a bit into machinery, CMake machinery, how you link those like Boost and Poker libraries in CMake, how you provide headers and so on? Because you included one CMake file and then you called one function.
Yeah.
Is this is all, or you do something else? Like how do you link with Boost?
Yeah, actually the link with Boost will be here. So if we go to the file, then we'll find for here we have the variable, and you have the Boost libraries and the Poco libraries defined there. You will have also like the include directories, and this macro here will set include directories. It will set up the variables we have just seen as include directories. If you don't want to do a global include directories because you don't want to do it target-based, for example, you can just grab the variables here and do it in your CMake. So instead of running this line here, you will just add options, add include directories to your targets, and add the specific CMake variables if you want. So actually what this helper macro is doing is like this. It's just setting include directories, setting link directories, add definitions. So it is kind of global definition. It is good enough for many projects. If you want more detail for your build, then you have to just take the variables and add them to your. So actually, this is a convenient macro, but it's not intended to be run the only way. So we separated like the variables in one side, and then the macro doing the typical stuff for quick projects. And so you get here the directories. We are also adding to the module path. So because you can use find CMakes also. You can add the find CMake to your package, and then your CMake project, it will not change at all because it will use the typical find CMake machinery. And then you only have to include this, and you will have to set the CMake module path. And it will be fine because it will find first the find CMake that is inside the package, not the regular one. So this is what I say. There are many things here. For example, we check for compilers and compiler versions, just a security check, because you can install, okay, I'm running with Visual Studio 12, okay, but then you open or you start a Visual Studio 14. You are going to have incompatibilities. So we are doing a check here. And I say, hey, you said that you are doing 12, but you are actually on 14. So practically half of this script is just settings check. Okay.
All right, thank you. And the second question is, how do you deal with a diamond dependency problem when you're doing transitive dependency?
How do we handle that?
Yeah.
Well, that's the core part of it. It is the dependency graph is a direct acyclic graph, so we don't handle cycles at all, and we think that we shouldn't. I mean, any dependency manager should handle cycles at all. So we handle the graph we have like a private dependency, so you can declare one dependency that is going to be private only for your, so you can actually have two different versions of the same packages, for example, for testing. You can have one node of the graph depending privately on gtest 1.5, and you can have another node depending privately on gtest 1.7, for example, and as long as the dependencies are private, the graph knows how to manage it. So we are building a direct acyclic graph from the root to upstream, closing the dependencies, solving like collisions. For example, what happens if you say, in this way, in a diamond, you say, I want setlib to be static, and in the other way, you say that you want it to be dynamic, you want to be shared. Then you have a conflict. So we check for that, and we say, hey, you have defined that it's going to be static, but this other node of the graph is saying to be dynamic. You have a conflict, and you have to resolve it downstream. So in these cases, you will add here, for example, if I had a conflict here, imagine boost is defining, in this case, setlib to be static, and Poco is defining setlib to be dynamic. I have to resolve the conflict myself. And I have to decide, I will do something like setlib shared to be true, for example. Okay? So we are building the graph upstream, resolving conflicts about options, about dependencies versions too. And then we are propagating from upstream to downstream all the build configuration. So like flags and include directories and library names, we propagate them back from upstream to the root node that is your project. We propagate everything down the graph so that's more or less the core of the dependency management inside Conan.
Right, so you can enforce it. Like if Boost say, I want to use static version of zlib, but you like on top level you can say I don't care, use dynamic, and it will.
Yeah. Of course, the user always has the power. If they want to overwrite any of the Boost or Poco options, you can do it. Yeah, and if you want to specify also the upstream version, or you can always the downstream things, they always have higher priority than the upstream. So the user has the power to define the build actually.
It's fantastic listening to Diego speak and listen to someone who has such a good understanding of the problems of package management and C++ projects. And anyone with a lot of C++ experience will recognize those difficulties. It's been a long time coming, I think, a good package management solution for C++. And Conan looks like an excellent tool. I think it's got a bright future. So it's very exciting. I met Diego earlier for the first time, and he's a thoroughly nice guy as well, so it's really nice to have him visit us here.
It was really good coming down to seeing and having Diego talk about Conan. It's a relatively new library package management system that's come out for C++ developers, so I think it provided a pretty good platform for him to talk about his product as well as add something to the C++ community.